Good morning, I am Barbara Russo. I'm professor of the Free University of Bolzano in Italy, and I'm here to present a work in collaboration with Matteo Camilli and Moritz Mock. The work is about WeakSAT, detecting weak self-admitted technical debt. So what is self-admitted technical debt? Technical debt is not quite the right code, for which the effort to make it right increases with time, like a sort of interest. Self-admitted means that developers admit in the comments that the following code is in fact technical debt. So in 2016, we found that SAT survives for long in a program. In this current initial work, we want to say that code blocks related to SAT contain weaknesses that might affect the security of the program. The two things together might send a message to developers that the longer a debt is not paid back, the higher is the risk the weaknesses can be exploited. So how do we define WeakSAT? How do we detect it? First of all, we mine the Common Weakness Enumeration repository, CWE, maintained by Mitre. This repository contains a lot of information and classifies different weaknesses. Also contains information about the code that define these weaknesses. By exploiting the information in the CWE, we defined a set of heuristics and the regex rules in order to identify in the code the lines of code that are weak, and we call them weak code. Then we use the SAT patterns defined by Potter Shiab in order to identify the SAT comments in the code. We use the tool srcml in order to obtain the blocks, and we use a proximity rule to associate the SAT comment to the code. And we call the blocks associated the code to the comment SAT blocks. Then we parse the SAT blocks in order to find the weak code in them, and we call the one, when we find it, we call it WeakSAT. This is an example. On the right, we have a code with a SAT comment on the top and the block on the bottom. On the left, you can see an example of the issue that contains a weak code, in particular contains a dangerous function, which is called memcpi. And we can find the same function at line 23 in the code on the right. So we built a tool that visualizes the comment, the SAT comment, the related code, so the SAT block, and the lines that are weak in the SAT block. We also defined GitHub actions in order to automatize our approach in CI/CD pipelines. The initial findings in Chromium over about 42,000 files, C files, we found we defined 34 heuristics for the CWE issues, and we used 61 SAT patterns. With this information and these tools, we were able to find 1.6% of the files that have SAT, 0.1 comments are SAT, and 26% of the files contain at least one weak code snippet. But the most important thing we want to say is that 55% of the SAT blocks do contain at least one weakness. And we found 14 different weaknesses in the SAT blocks. And some of the SAT blocks contain more than one weakness. So at the end, SAT blocks do contain weaknesses that may affect the security of the program. This is a message to the developers and conclude also our presentation. Thank you.